Hi everyone, this video is an exercise 11K question 9. So we have a modeling question, and it's about fossils which are aged using a process called carbon dating, and the amount of carbon remaining in a fossil or decreases over time. And basically time is measured in years. The rate of decrease of carbon is proportional to the remaining carbon. So this is very important in terms of forming the equation. So in part A, given that initially the amount of carbon is R0, show that R is equal to R0 e to the minus KT. Okay, so we need to form the differential equation. Remember that the question is about the basically the rate of change of R with respect to T. So R is just the amount of carbon remaining in a fossil. So we basically have dr by dt. And now for the right hand side, remember that the rate of decrease of carbon is proportional to the remaining carbon. So remember that the remaining carbon is shown with R, and it says that basically it's proportional to that. But the reason that we write negative Kr is because the amount of carbon remaining in a fossil decreases over time. So this negative is because of the decreasing amount, and then K is just a constant of proportionality in this case. So that's how we form this. Now we need to solve this differential equation. So we can divide both sides by r and also multiply by dt. So once we integrate, we'll have ln r on the left hand side. So r is positive. We don't need uh, log, sorry, modulus, and then minus k dt integrates to minus kt plus the constant of integration. We can use r0. That's essentially what they have used here. Now at this point, or maybe it's actually better to use something like, let's say, c. Again, these are just arbitrary constants. And then once we do e to the power of both sides like this, so the left hand side becomes just r, and the right hand side will be r0 times e to the minus kt. So k is the constant of proportionality. R0 is basically is just a constant of integration, but now just to be consistent with the notation they have used, we'll use R0. And R0 is also the initial amount of carbon in basically in fossils. So it has actual meaning in this context, because normally the constant of integration is just a constant, but in this case, because it's a modeling question, then this is important. Now in part B, we are told that it's known the half-life of carbon is 5,730 years, and it means that after this amount of years, the amount of carbon remaining has reduced by half. So in part B, we want to find the exact value of K. Okay, so what's happening here is that basically the half-life is 5,730 years. And essentially, after this amount of year, R is going to be equal to R0 over 2. So remember, R0 is the initial amount, and then R is the new amount. So the new amount after this many years is going to be the initial amount divided by 2, because that's just the meaning of a half-life. Now, we can use this to substitute into our equation that we derived in the previous part. So we can substitute R into here, and we'll have R0 over 2 is equal to R0 e to the minus k times 5,730. Right, so now we can solve this equation to find a value of k. So because this part is all about finding k. So we can the two r's are just going to cancel. So R0 with this R0. And we'll have basically take ln of both sides. So we'll have ln half is equal to ln of the right, just gives us minus k times 5,730. And now we can just divide both sides by this value, so minus, so k is equal to len half over minus 5730. And we can actually rewrite this as len 2 over 5730, because it's just a property of logs that if you have negative log here, then that negative can be on the power basically, and then a half to the power minus 1 becomes len 2. So k is equal to len 2 over 5730. Finally, in part C, a fossil is found with 10% of its expected carbon remaining. So it's very similar to the previous part. Determine the age of the fossil to the nearest years. So now, again, this is giving us the new value of R. So this is basically 10% of its expected carbon. With 10% of its expected carbon remaining. So basically just saying that we have 0.1 R0. So because that's just 10% of the initial amount. Now again, we can substitute this into the equation. The main equation is here. So we'll have R0 over 10 is equal to R0 e to the minus KT. And again, we can just divide the R0s. So we'll have 1 over 10 is equal to e to the minus kt, but we can multiply by 10, so we'll have 1 is equal to 10 e to the minus kt, and then let's divide both sides by e to the minus kt, and that gives us e to the kt, so the power becomes positive because we are dividing, is equal to 10. And remember that we first need to take len of both sides because we want to know the value of t. We have already found the value of k. So when we take len, we'll have kt is equal to len 10, and then t is equal to len 10 over k. Now k is what we have found here. So that's len 2 over 5730. So that's, and that will be here. So, and now we just use calculator. So this approximately gives us 19,035 years.